Okay, so Pluto, that far off, confusing little planet, well, dwarf planet now, is back in the news. You remember Neil deGrasse Tyson and Michio Kaku? Well, they've been talking about Pluto again, saying that it might actually be on a crash course with Neptune. How could that even happen? And what would it mean if those two actually collided? Is this just some weird space thing, or is there more to it? Pluto's always been a bit of a weirdo because of its unusual orbit. And these experts are saying it's getting dangerously close to Neptune's path. Tyson and Kaku are ringing the alarm bells about a possible crash that could have results to Earth. How could this happen? Pluto takes a crazy 248 years just to go around the Sun once. Since we found it in 1930, it hasn't even finished a single trip. Plus, its orbit isn't round like the other planets, it's kind of tilted at a weird angle. Here's a crazy thing, for about 20 years of its orbit, Pluto is actually closer to the Sun than Neptune. So why haven't they crashed yet? Other planets' gravity is what keeps Pluto in check. When they first found Pluto, they started trying to figure out its strange orbit. It's way different from the other planets, its path is tilted and not very round. And yes, it crosses Neptune's path. The fact that Pluto's orbit stays stable is a testament to how space stuff works. Think of it like this: Pluto, Neptune, and the Sun are all pulling on each other. Pluto's path is a bit wild, and even small changes could make a big difference over millions of years. But for some reason, it stays steady. Simulations have helped us see how the big planets, Neptune, Jupiter, and Saturn, keep Pluto from going totally haywire. Jupiter's gravity is strong enough to keep Pluto on a stable path for a long, long time. Without these forces, our solar system would be super chaotic. Pluto's orbit is a great example of how space is both stable and a little bit crazy. The gravity of other planets, especially Neptune, keeps things interesting. It's hard to guess what will happen way in the future, especially with something as wild as Pluto's orbit. But even though these systems are hard to predict, these computer models can still teach us a lot. So, why are Tyson and Kaku only now talking about a possible crash? Even with everything working to prevent it, they're worried. If Pluto and Neptune did collide, it would be huge. Pluto would probably break apart because it's smaller and made of ice. The debris would spread all over the solar system and could be dangerous to other planets and moons. Neptune's atmosphere and orbit could also change. Kaku's views on space travel and how space mechanics connect to theoretical physics can give value on things like Pluto's orbit. Understanding how planets move and interact can help us plan space missions better, avoid problems, and even visit planets far, far away. What we learn from Pluto can help us look at other planets, too. Celestial mechanics and theoretical physics are linked. How planets move, including Pluto and Neptune's dance, has to do with basic physics. If Pluto and Neptune smashed into each other, it would be a huge thing for scientists worldwide. String theory, which tries to explain the universe, could become testable for conditions of extreme energy and gravity. We're far enough away that it wouldn't hurt Earth, but it could teach us a lot about the universe. Pluto's weird orbit still fascinates scientists. Even though it's just a dwarf planet, recent discoveries have people interested again. Tyson and Kaku are worried about a possible crash, so understanding how gravity and orbits work is super important. Pluto's chaotic, tilted orbit is unlike the other planets. It crosses Neptune's path, and Neptune's gravity helps keep it stable. Computer models help us guess what might happen in the future. They show that Pluto's orbit, while a bit wild, stays pretty stable. A crash is unlikely, but it shows how delicate everything is in space. Studying Pluto also helps us with space exploration. The New Horizons mission gave us amazing pictures and information about Pluto and its moons. We learned about its mountains of ice and frozen nitrogen fields. This mission showed what we can do with technology and teamwork. By studying Pluto, we learned about other planets and conditions in the outer solar system. This helps us plan future missions to other dwarf planets. Pluto's status as a dwarf planet has made us rethink how we classify planets. It meets some of the requirements, but it's still different from the main 8 planets. Studying Pluto's orbit helps us learn about space mechanics and dynamics. By looking at how Pluto, Neptune, and other things interact, we can learn about how the solar system formed. The gravity of Neptune on Pluto's orbit shows how planets can change the paths of smaller objects. Researching Pluto's orbit and a possible crash with Neptune can help us fine-tune how we understand planets. As we keep figuring out Pluto and that part of the solar system, we might learn secrets about the universe. A collision of the planets, though unlikely, would be a monumental event that could give great opportunities for discoveries. Whether or not it happens, studying Pluto's orbit and its relationship with Neptune will keep inspiring scientists as they try to unlock the secrets of our cosmic neighborhood. Okay, so Pluto's a weird little planet. It used to be one of the main planets but got demoted. Now, some pretty smart people, like Neil deGrasse Tyson and Michio Kaku, are saying Pluto might crash into Neptune. How could that even happen? And what would it mean if it did? Is this just a weird thing in space, or is something else going on? Pluto's a bit of a mystery because its path around the Sun is strange. It takes 248 years to go around once, and its orbit is oddly shaped and tilted compared to the other planets. What's really strange is that Pluto's orbit crosses Neptune's. For about 20 years of its orbit, Pluto is actually closer to the Sun than Neptune. So why haven't they crashed? Other planets keep Pluto from bumping into Neptune. When Pluto was first spotted, scientists tried to figure out its weird orbit. Unlike the other planets, Pluto's path is tilted and not round. It was even more confusing when they realized Pluto's orbit crosses Neptune's. It's pretty amazing that Pluto's orbit is stable, considering everything. The way Pluto, Neptune, and the Sun pull on each other is complicated. Pluto's orbit can be a bit chaotic, and small changes could make a big difference over time. But it stays steady for a long time. Recent computer models show how big planets like Neptune, Jupiter, and Saturn affect Pluto's orbit. Jupiter's gravity is strong enough to keep Pluto on track for billions of years. These forces are critical for keeping our planetary system in order. Without them, things would be much more chaotic. Pluto's orbit is a great example of how space works, showing both steady and weird movement. The strange orbit, influenced by Neptune, shows how complex and changing space is. It's hard to guess big events, especially with wild orbits like Pluto's. These systems are hard to predict, so long-term guesses are often wrong. Computer models help, but they also have limits. So, why are these scientists worried now? Even with all the things keeping Pluto and Neptune apart, Tyson and Kaku are concerned about a crash. If Pluto and Neptune crashed, it would be a crazy, destructive thing. The smash would release tons of energy, and Pluto would probably break apart because it's small and icy. Pieces from the crash could spread around, maybe even hurting other planets and moons. Neptune's air might change, and maybe even its orbit. Kaku has interesting ideas about space and how it all connects. He says Pluto's orbit could help us figure out space travel and other mysteries. Understanding how planets move can help us with space travel, predict problems, and plan trips far out into space. What we learn from Pluto can help us explore other planets. The way planets move connects with physics. The movements of planets, like Pluto and Neptune, relate to basic physics. If Pluto and Neptune crashed, it would be a gigantic event. It might even help us find clues about string theory, which tries to explain the basic forces of the universe. The crash could create extreme conditions, perhaps letting us detect things string theory predicts. Even though Earth wouldn't be affected much, it could help us understand the stuff the universe is made of. Pluto's wacky orbit continues to fascinate people. Even though it's not a main planet anymore, recent discoveries have made it interesting again. Tyson and Kaku are warning us about a possible crash between Pluto and Neptune, showing how complicated our corner of space is. Their warnings remind us to understand gravity and how planets move. Pluto's strange and tilted orbit goes against what we expect. Unlike the round orbits of other planets, Pluto's path crosses Neptune's. Neptune's gravity keeps Pluto steady over time. Computer models help us guess what will happen to planets and understand how they interact. These models show that Pluto's orbit is wild but stable in the long run. A crash between Pluto and Neptune is not likely, but it shows how fragile things are in space. Studying Pluto also gives us helpful information for future space trips. The New Horizons spacecraft gave us awesome pictures and info about Pluto and its moons. It showed us mountains of ice and frozen nitrogen, helping us learn about this distant planet. The New Horizons mission showed how cool space exploration is. By studying Pluto, we learned about planets and conditions far away. These discoveries can help us plan trips to other dwarf planets and objects, teaching us about how planets form. Pluto's status as a dwarf planet has people talking about how we classify planets. The discussion shows how science changes over time. Pluto fits some rules for being a planet, but its dwarf planet status shows how diverse space is. Studying Pluto's orbit grows our knowledge of space to the outer reaches. By looking at how Pluto, Neptune, and other objects interact, we can learn about how planetary systems form. Pluto's discovery has added to our understanding of how planets move and the formation of the Kuiper Belt. The way Neptune affects Pluto's orbit shows how planets can shape smaller objects. Future research on Pluto's orbit could help us better understand planets. As we explore Pluto and the outer solar system, we may uncover new things about the universe. A crash between Pluto and Neptune is unlikely but could lead to big discoveries. Whether it happens or not, studying Pluto's orbit will continue to inspire scientists as they try to learn about our cosmic neighborhood.